My name is Miles,
And my name is Nishant.
and we are from Quest Academy, which is located in Palatine, Illinois, and we are sixth graders. Our device is called the Trackstenium 2000.
Our problem was that people were losing items continuously, and it can either be because it was stolen or due to carelessness, but the one conclusion is that it can be really stressful to find. So we wanted to come up with a device that could track your items/possessions. Our solution was a hassle-free small device linked to an app that can track your items via GPS. It can track jewelry, cars, pets, planes, you name it. It can track anything.
On the screen, you can see most of the people that we surveyed have lost an item before, and our market potential is probably travelers, business people, or anybody that goes on a day-to-day commute. Our sources were USPTO.gov, Amazon.com, Google.com/pens, and New York Times. Similar items to ours is tile, but ours is different from that because ours is not sound-based, and you can track your belongings from a greater distance. There's also Tracky, and ours is different from that because you can track more things than Tracky can track. And then from Find My and the new Apple AirTag that came out this week, ours is different from that because you can track it on more than just Apple devices. But more similar to the AirTag, ours is not Bluetooth based.
Our prototype consists of the Node MCU, which is $4.67, the U-Block 6M GPS, which is $9, and jumper wires, which each of them is 10 cents each. However, our prototype consisted of materials that were used just for the prototype, but our real model will consist of just the U-Block 6M Neo GPS with no wires or Node MCU, and it'll also have more sleeker and durable material for the case, but we'll still coat it with the Arduino IDE and use the blink-free application.
So then our build process. Up on the top right is what we thought it was going to start looking like, a smiley face. Then on the bottom left and the logbook, we thought it would be more like a backpack sort of looking item. Then down here on the bottom right, you can see what we came up with for the casing. And on the top left, it's Nishant displaying the Blink app.
Our prototype consists of the Node MCU ESP8266, female-to-female jumper wires, U-Block 6M Neo GPS, cardboard for the case, and coated with the Arduino IDE. It also uses the blink-free application that is able to show the longitude, the latitude, the direction, the speed, and the satellite it's connected to. It's also able to precisely track your device via a GPS map.
So testing. Nishant drove to Quest to test our device. He's a little bit more than 2 miles away from Quest, and it worked, so we know our device can track more than 2 miles. We also know it has a 98% accuracy, and the delay is less than 1 second.
So, some future iterations include that we don't want to make it just internet-based, so we want to add a mini hotspot so it doesn't rely on one's Wi-Fi. We also wanted to make it waterproof, increase the protection of our app, increase the orientation of our app, and make it a little less smaller than it is now. And some feedback we got was that don't try to make it too intricate, make the orientation a little well done. I like this idea a lot. And make sure that it doesn't just rely on one's Wi-Fi.
I hope you enjoyed our pitch video. Thank you for listening.